So this was the paper, we had it on the other day, right? Yeah. So we'll discuss it. Okay, this would have been, the first one would have been a tough one for you. No problem. That's Newton meter square per coulomb square. Okay. So you learn about this, don't worry. The answer is Newton meter square per coulomb square. Okay. So that is no. Pi has nothing to do. 4 pi is a constant, but epsilon naught is there, no? That has some. So it is actually called as 1 divided by 4 pi epsilon naught. Forget about this question. Answer is Newton meter square per coulomb square. Okay. Now, you have learned units and dimensions. You have learned units and measurements. Did they complete it? Halfway. What have they taught? Till where is it completed? Dimensional analysis. So these are all based on dimensional analysis. Okay. So take your notes and start writing. So read this question carefully, and I want everybody to discuss with me. Read it carefully. I'll give you 2 minutes time. So the velocity of sound in air depends on the pressure and density. Which of the following relation would be correct? So what are the steps to be followed? Yes. So first of all, V is directly proportional to what? I already told you in the previous class also I explained. You will learn it now. So it is like this. Velocity. So read the question. Velocity of a sound depends on pressure and density. So velocity is directly proportional to density to the power A, pressure to the power B. Okay. So it depends on density, but we don't know how many times. So it is raised to the power A, and it is dependent on pressure. We don't know how many times. So it is raised to the power B. So V will be equal to K times rho power A into P power B, where K is a what constant? It is a dimensionless constant, means it does not have any dimensions or units associated with it. Okay. Then for the equation to be dimensionally consistent, what should happen on both the sides? Sorry? Exponents are supposed to be same. So you write it as dimensional formula of V. You know this symbol? That is called dimensional formula of V is equal to dimensional formula of rho raised to the power A into the dimensional formula of pressure raised to the power B. Okay, right now, fill this step.
Recording in progress.
Those who are online,
Yeah, understood, sir. Understood the question, sir.
okay. Right. So what is the dimensional formula of V?
L into
So-
T to the power minus 1.
Yes. So V is equal to rho into, K into, what did we write? K into rho power A into P power B. And dimensional formula of V is equal to K into dimensional formula of rho to the power A into the dimensional formula of P to the power B. So what is the dimensional formula of V? It is L T minus 1. So how to recollect? V is speed. Speed is meter per second. Meter is replaced with L and second is replaced with time, power minus 1. So LT minus 1 is equal to, what is the formula for density? So what is density? Whatever you know. What is density? This mass by volume, right? So mass is M, volume is measured in L cube. So M divided by L cube, or it is ML minus 3 into, how is pressure measured as? What is pressure? Force per. So pressure is force per unit area, but what is force? MLT minus 2 divided by L square. So it will be ML minus 1 T minus 2. Okay, this should be raised to the power A, this should be raised to the power B. Because density power A, pressure power B. Okay. So this will be LT minus 1 is equal to M power A, L power minus 3A into M power B, L power minus B, T power minus 2B. Right? This is M0 L1 T minus 1 is equal to M power A plus B, L power minus 3A minus B, and T power minus 2B. So A plus B is 0, minus 3A minus B is 1, and minus 2B is minus 1. So when I compare, A plus B is 0, minus 3A minus B is 1, and minus 2B is minus 1. So when A plus B is 0, A will be equal to minus B. Minus 3A minus B is 0 is minus 3A is equal to 1 plus B. Or I can write it like this, no? When A is equal to minus B, can I take this and substitute it here? So it will become 3B minus B is equal to 1, which implies 2B is equal to 1, or I can say B is equal to half. If B is equal to half, A is minus half. So I could have got it from here itself. Minus 2B is minus 1. So B is half. So A plus B is 0 means A is minus B. So if B is half, if I substitute it here, A will be minus half. So take all these values and substitute it in this equation. When you do this, what will you get? V will be equal to K into rho power half into P power minus half, or it will be K into root of rho divided by P, which is V. Right. Okay. Shall we proceed? So what is the answer? Directly proportional to rho divided by
B, sir.
Which one is the answer?
Option B, sir.
But it is P by rho, no? We got rho by P. Oh, I made a mistake then. It is P divided by rho. So option B is the right answer. Okay. Next. Next is the velocity of a particle is given as at square plus bt plus c, where m is measured in meter per second and t is measured in second. The unit of A and B are same, but that of C is different. Is that right? So when V is equal to at square plus bt plus c, what is the unit of V that is given meter per second is equal to A into, what is the unit of time square? What is the unit of time given? It's given there. So S night should be S square plus B into the unit of time should be second plus C is a, what should be the unit of C? It should be meter per second. So what? Last class I told you one important point. What is that? You can add physical quantities only if they are of same dimension or same unit. You cannot add velocity to acceleration. You cannot add displacement to velocity. Okay. If that should be the case, if this is velocity, okay, if this is velocity, this should also be the product of A into T square should also be velocity. Product of B into T should be velocity, and C itself should also be velocity. Okay. So if I say meter per second is equal to A into S square, then what would be the unit of A? It will be meter per second cube. Similarly, meter per second is equal to B into second. So unit of B should be meter per second square. Right. So what is the unit of, now check what are the right options. A and B are same, but C is different. Is it right? Because A is meter per second cube, B is meter per second square. So option A is wrong. What about option B? B is meter per second. Is it right? Wrong. A is meter per second, right? A is meter per second. What is there in the meter per second? Cube. So this is wrong. So what is the right answer? C is meter per second. So that is the right answer. Actually, we need not even solve this. But to explain the other meanings, I did it. Okay. So C is meter per second is the right answer. Please make a note of it. Tomorrow is a holiday. Everyone. For you, is it a holiday? No, no. Can I rub this for you? No? You have school, no? Can I remove this? Should I proceed? Can I go a little fast? It's too slow for my pace. A man walks 4 kilometers due west. Due west, he walks 4 kilometers. And 500 meter. So 4 kilometers, how many meters? 4,000 meter. And from there, he walks due south by, and how much distance is he covering? 500 meter. And finally, 875 in the southwest direction. Okay. So which is southwest? Should I go left hand side or should I go this side? See, if this is you, okay, with respect to you, take your left hand and tell me which side am I supposed to go. Should I go to your left or should I go to your right? What is southwest? So southwest is to the left. By what angle? 45 degrees. Okay. So it is 500 meter and this distance is how much? It is 875 meter. So what is going to be the answer? What is the distance, guys? Distance is sum of the total path. 4,000 plus 500 plus 875. How much is the value? 4,500 plus 875. It is going to be 5375. Is that right? Is there an option? Yes, 5375. I'm able to see two options. Right. Now, what would be the right answer for the displacement? So, how to find displacement?
Shortest.
Shortest path, but you don't know where he is going and landing, no?
Yes, sir, it's like a triangle, sir, when you draw it. So it's like we can use Pythagorean theorem and also the 875, sir.
Very good. So, this is 4,000. Okay. Now, I'm not putting this thing. So, this is 4,000. Right. This is 500. And this is 875. Okay. So, I need to know what is the horizontal distance covered by him. If I know that to this 4,000, if I add this horizontal distance, I'll get the displacement. Okay. So answer by now you can guess it. At least what would be the answer? What would be the answer? At least guess. You need not do the
Sir, C, sir. 906.
Why C? You tell me the logic.
Wait, sir. Okay, sir. Okay, wait, sir.
It is greater
Sir,
than 4.
when what, sir?
It is greater than 4,000. You already 4,000 meters is covered
Yes.
here. So some more distance should get added for it to become the displacement. Is that right? Yes. So answer should have been 4,906 actually. Okay. So this should be the answer. Actually, there is a mistake, Pavingla, when I didn't check. See, if you take the basic system, this is north, south, east, west. Which is southwest? I drew the diagram in completely reverse. You never told me. So the person is starting here. He traveled this distance by 4,000, this by 500, and this distance by 875. So you need to find if this is 45 degrees, okay. So what you need to do is, you need to take this as x. So x divided by 875 will be equal to cos 45 degrees. So x will be equal to 875 into how much? Cos 45. Cos 45 is 1 by root 2. So 875 into 0.707. If you do that and add it to the 4000, that would be the required displacement. Okay. So there is actually a problem that is based on two logics. One is you need to know how to calculate the displacement, that is the shortest path, and the second is based on trigonometry. Right. So the next one. Try the fifth one. The location of a particle is changed. What can we say about the displacement and distance covered by the particle? So read the question carefully. I didn't get you. How to do? Idea, logic student. What do you understand from the question? So what is it? So what do you infer from it? There is a particle and the particle's position is changed. So they didn't give any other information as beside that. So with that, what can you conclude? If the position of the particle is changed, what should happen to the distance? What can you say about distance? Distance is the path traveled by the particle. Is it changing or not? So can you say distance is 0 anymore? No. So if one is positive, the other is negative and vice versa. So read the question. What can we say about displacement and distance covered by the particle? What is displacement? Displacement is vector. Vectors have both magnitude and direction. They will only get sign. What about distance? Distance is a scalar. For scalar, you cannot say positive or negative. So the first option, if one is positive, the other is negative and vice versa, wrong. Because distance doesn't have any direction. Both must be 0. No, because the particle has moved. What about both cannot be 0? There is a possibility. Yes, we can have that on hold. One of the two may be 0. That is also possible. But more appropriate among both is both cannot be 0. They told one of them may be 0, that one of them can only be possible for a displacement. Distance cannot be 0. So that is why out of both the options, which one is more sure? C. Yeah. Shall we proceed? So there is a jet that lands on an aircraft carrier at 63 meters per second. So that is the speed. What is the displacement of the plane in meter while it stopped in 2 seconds? What can you say? So there is a jet that lands on an aircraft at 63 meters per second. So V is equal to 63 meters per second. What is the displacement when it stopped in 2 seconds? So how to calculate? Distance is equal to speed into time. 63 into 2. It should be 128, but there is 128. Okay. Okay. So I read the question wrongly. So they mentioned it that it stopped in 2 seconds. Means is it decelerating or accelerating? it decelerating or accelerating? So decelerating, what is the value at which it is decelerating? V is equal to, if I apply V is equal to U plus AT, V is what? When it stops, final velocity is 0. What about the initial velocity with which it started? 63. Plus, what is the acceleration of the particle? That's what you need to find. Into time is how much? 2 seconds. So A will be how much? Minus 63 by 2. So minus 63 represents, negative represents that it is decelerating, right? So minus 63 by 2. And they are asking the distance traveled by it. So S is equal to UT plus half AT square. Displacement is equal to, what is U? 63 into time is 2 plus half into acceleration is minus 63 by 2 into T square, that is 4. This 4 and this will get cancelled. 126 minus 63 is 63. What is the answer? 63 kilometer is what is the answer. Sorry, 63 meter is what is the answer. Are you able to understand? So I know some of you have not learned this thing, but I'm using the basic kinematic equations. There are 3 equations, you know them, right? V is equal to U plus AT. You would have learned in your lower grades. V is equal to U plus AT. S is equal to UT plus half AT square. V square minus U square is equal to 2S. So these are the 3 equations. So wherever you see the word an object comes to rest or stop, the first equation that should come to your mind if time is given is V is equal to U plus AT. If the distance traveled is given, the equation that you need to apply is V square minus U square is equal to 2S. Shall I proceed? So eighth one is easy. There is a lift that is coming from 8th floor and is just about to reach the 4th floor. So it is coming in the downward direction or upward direction. Obviously 8th to 4th round. You are in 8th floor, you want to come to 4th floor, you come in the downward direction. Taking ground floor as origin. Okay. And upward as positive direction. So observe it again. You're taking the ground floor as origin and upward as positive direction. Remember that the lift has traveled in the downward direction. Now, what can you say about the sign of displacement, velocity, and acceleration? So, is the particle displaced in positive direction or negative direction? X is so displacement is negative. Okay, displacement negative means which options are there? Only C mattumda. So displacement that is greater than x bar. Displacement is negative. What about velocity? Velocity cannot be seen because if you drop an object, right? If an object is traveling in vertical direction, it will travel under the influence of whom? Gravity. So gravity is accelerating. Means if an object is moving in the downward direction, its speed will increase. See, if you take a ball, okay, you hold it like this, you release it. What will happen to its velocity? Ball, you release it. You release the ball with what velocity? What velocity? when you remove your hand, what is the velocity you gave to the ball? Nothing. You dropped the ball. Dropped in the sense zero velocity. But is it traveling with zero velocity? Obviously, no. It is going fast and it goes and hits the ground. You'll be able to hear the sound. Okay. So if at all you want to hear more sound, what if you give more velocity, you can hear the sound more better because its speed is increasing. So whenever an object is traveling in the downward direction, it will accelerate. So accelerate means its velocity will increase. So what can you conclude? X is less than 0, velocity is less than 0. Actually, the answer should have been acceleration. In terms of direction, should be less than 0. This should have been the right answer. But why they would have given it as A is great? Coming from 8th floor. Sorry, B is velocity. Option B is wrong, no, because they told upward direction is positive. Lift is traveling in the downward direction. Why? But which direction? Direction. If you take the arrow mark, that arrow mark is pointing in which direction? It is pointing in the direction of below origin. It's pointing in the direction of negative y-axis. So simple, right? If upward is positive, now you put an upward arrow and take it as positive. Downward, what a downward arrow is negative. That's it. Okay. So option C is the right answer. Okay. Next is, there is a truck that covers 40 meters in 8.5 seconds while smoothly slowing down to a final speed of 2.8 meters per second. What do you mean by smoothly slowing down? It is decelerating, but at a uniform rate. Slowly in reward meaning it is decelerating at a uniform rate. Find its original speed in meter per second. So you need to apply two formulas. What are they? Distance by time, because the object is decelerating. First, why apply V is equal to U plus AT? Because they have given final velocity and they have given you time. So you first collect the data. So when you take the data, what are you trying to say? Truck covers 8th or 9th? Which question is 9th, no? Truck covers 40 meters in how much time? 8.5 seconds. Okay. And what is the speed at which it is reaching the final point? 2.8 meter per second. How much time? It took 8.5. So if I apply V is equal to U plus AT, what can I say? V is 2.8 is equal to U is, we don't know, plus acceleration, we don't know, into time is 8.5. Okay. So can I say U is equal to 2.8 minus 8.5A? Let me call this as equation number 1. Is it clear till this time? Right? Now the next question is, find the original speed is what they are asking. If I apply S is equal to UT plus half AT square, okay. Now see, since they are asking the original speed, what I would say is, find A in terms of U. So 8.5A is equal to 2.8 minus U. So A will be equal to 2.8 minus U divided by 8.5. Is that point clear? Just a mathematical calculation. I'll call this as equation number 1. Now listen to this. S is equal to UT plus half AT square. How much distance did it travel? 40 is equal to U is what you need to find into how much time did it take? 8.5 seconds plus half into acceleration is 2.8 minus U divided by 8.5. into t square, that is 8.5 square, 8.5, and this will get cancelled. So what I left out with, if you take 2 and multiply, then you will get 80 is equal to 17u plus 2.8 into 8.5 minus 8.5u. So 80 minus 2.8 into 8.5 is equal to 8.5u. So from this, you can find the value of u. I'll give you 2 minutes time. Calculate and tell me first. How much? So 80 minus, how much is 2.8 into 8.5? Do it fast. 50? 57.2. It's 23.8 is equal to 8.5u. So 80 minus 23.8, 56.2 is equal to 8.5u. So is there an option? 56 divided by 8.5. It should be somewhere around 7 varadu. Had it been exactly 8, 56 by 8 would have given you 7. But 56.2 divided by 8.5 will be less than 7. So less than 7, what is the option available? So it could have been 5.61 also, but since it is 8.5, it will only be slightly less than 7. So that is why it is 6.61. Are you able to understand how to guess? Okay. Next is 10th one. Magnitude of force experienced by a certain object with a speed v is given by F is equal to k into v square, where k is a constant. Then the dimension of k is what? So F is equal to kv square. So for it to be dimensionally consistent, what should happen? The dimensional formula of F should be equal to the dimensional formula of k into the dimensional formula of v square. So what is the dimensional formula of F? MLT minus 2 is equal to dimensional formula of k into dimensional formula of v square. That is LT minus 1 the whole square. Is that clear? So MLT minus 2 is equal to dimensional formula of k into L square t minus 2. So what is the dimensional formula of k? M L minus 1 0. So t power minus 2, t power minus 2 will get cancelled. It will be ML minus 1. Is there an option? Oh, no option. It is ML minus 1. Got it? Those who are online are able to understand? Abhinav and Hariharan?
Yes, sir.
Good. Shall we proceed?
Okay, sir.
State dimensional formula for stress, strain, and Young's model. I don't think you would have done it. Okay. Let's leave it. I don't want to stress your mind by it. It is in the 11th chapter. Don't worry about it. I'll explain it. Stress and strain. Stress and Young's model will have the same. Stress is nothing but pressure. Strain is change in dimension by original dimension. It doesn't have dimension at all. So stress and Young's modulus have the same value, but it's okay. Can Earth be regarded as a point object when it is describing its yearly journey around the sun. Why? So Earth is revolving around the sun. Here the point is, in kinematics, there is an important rule. What is kinematics? Motion in a straight line. You can consider any object to be a point object if the distance traveled by the object is very large compared to its own size. If the distance traveled by the object is very large compared to its own size, it can be treated as a point object. So here point object is a relative term, it's not an exact term. So compared to the radius which it is going to cover, Earth is a small object. That is why it is taken to be a point object. In this question, the answer is yes. So what would be the reason you will give? Because it covers large distance compared to its own size. So please make a note of that. So what is the meaning of this question, the 13th one? What is the numerical ratio of velocity to speed of an object? What are they even asking? Numerical value, na? What is the meaning of numerical value? It is dimension. Magnitude of velocity divided by magnitude of speed. Magnitude means if velocity is, let's say, minus 5.1. What is the magnitude of velocity? Magnitude means modulus. So modulus will be plus 5.1. Okay. So one point that is to be noted here is distance is always greater than or equal to displacement. If I divide it with time on both the sides, I can say speed is always greater than or equal to velocity. Okay. If I divide with speed on both the sides, one is greater than or equal to velocity by speed. So what would be the numerical value? The ratio of velocity to speed is, look at the inequality and tell me. Velocity divided by speed is less than or equal to 1. So if at all you see a question like this, what are they asking is, the ratio of velocity to the speed is less than or equal to 1. Did you understand the logic or not? I repeat it again. Distance is always greater than or at the max equal to displacement. Because when you travel from one point to another, irrespective of the direction in which you're traveling, the distance is always positive. It keeps on adding. Whereas, let's say you're going in the forward direction and coming back in some direction, the displacement, what will happen is the forward direction will be positive, in the reverse direction it will be negative, so it will get subtracted. Overall value will reduce. If only logically see, this is the track. If the object is going from point A to point B, okay, it has covered, let's say, 10 centimeters. And from point A, and let's say it has covered half the distance, 5 centimeters. Now, what would be the distance? 10 plus 5, 15. But what would be the displacement? It is 5. So that is why I told displacement is always less than or equal to. When will displacement be equal to distance? When the direction of object has not changed. For example, if the object has traveled from point A to point B, let's say it has covered 10 centimeters. What is the distance? What is the displacement? So in that scenario, distance is equal to displacement. So only two possibilities. Either distance can be greater than or at the max equal to displacement. If I divide with time, distance by time is called as speed. Displacement by time is called as velocity. Okay. So if I treat it like equality, if I divide with speed on both the sides, what would have happened? Velocity by speed would have been equal to 1. But it is not equality, it is inequality. So it is why it is less than or equal to. So what will you say, Adam? What will be the answer? The numerical value is less than or equal to 1. That is the expectation. Seriya? So write it down. Breathe. Shall we proceed? Read the next one. 14th one. Is it possible that the body has constant velocity but varying speed? Think about it. Velocity and speed sound to be similar, but they're different. What is velocity? Velocity is speed with direction. Right? So when you say velocity is constant, what can you say? Speed of the object is constant and direction is also constant. Okay. So when velocity of the object is constant, how can you say speed will change? Is it possible? Please make a note of it. The answer is no, because speed is the magnitude of velocity. Speed is the magnitude of velocity. Am I clear with this point? Now I want to ask you another important thing. Is the reverse thing possible? Speed of the object is constant. Can velocity change? Yes or no? Direction can change. Speed of the object is constant, but velocity can change. Example, uniform circular motion. In your exhibition, you have seen the change you expect. So let's say they are revolving with uniform, they are revolving in a uniform circular motion. What do I mean by uniform is, if you try to calculate the speed at every point, it will be the same. But what will happen, the direction will change. So if you want, you can make a note of it. But the reverse is possible. That is, velocity of the object, that is, speed of the object can be same. Speed of the object can be same, but velocity might change. Velocity can change. Okay. So look at the 15th one. The 15th one, you have velocity time graphs. Okay. So for a velocity time graph, what does acceleration represent? You have velocity time. For a velocity time graph, what is acceleration? It is slope. So in a VT graph, there are two objects which are making 30 degrees and there is another object which is making 60 degrees. Okay. When it is making 30 degree with the time axis, the ratio of their acceleration. So if I take this as A1 and A2, A1 by A2 is equal to, what is slope of a line? Slope of a line is Cayley-Buttrick slope. You have heard of slope? Yes or no? You have heard? So slope is basically defined as tan theta, tan of the angle made by the line with x-axis. So it will be tan 30 divided by tan 60. What is tan 30? 1 by root 3. Tan 60 is root 3. 1 by root 3 into root 3 is 1 by 3. So A1 by A2 will be 1:3. 16th one, what is the answer? Let them complete. If the instantaneous velocity of particle is zero, is the instantaneous acceleration necessarily zero? If you say no or yes, whatever reason you give, whatever answer you give me a valid reason for it. If the instantaneous velocity of a particle is zero, means at a particular instant the particle is having zero velocity. At that instant, can I say that the acceleration is also zero? Your guess? Yes. What about your guess? Yes, sir. No. You're thinking whatever it is, right? Hari, what is your guess? Yes, sir. What about Abhinav and Hariharan? Abhinav,
Yes, sir.
what is your guess?
1 second.
Yes, sir. Okay. So I'll give you a scenario. You have a ball in your hand. You throw it in the upward direction. Okay. When the ball reaches the highest point, at that instant, what would be the velocity? But what about the acceleration? The acceleration is not equal to zero because the ball is still under the influence of gravity. It is still accelerating or decelerating. So this is one such example where you can say if instantaneous velocity is zero, it is not necessary that the instantaneous acceleration will also be zero. So why I'm giving you this example is always our mind starts thinking in terms of mathematical parameters. No. Start thinking in terms of real-time examples. Did you understand what I told? If an object is thrown in upward direction, it travels upward. At the instant it has to change its direction, at the instant it reaches the highest point, its velocity will be zero, but acceleration is still acting in the downward direction. That is the acceleration due to gravity. Write down the answer. Answer is no. Because when the ball is thrown upward, its instantaneous velocity is zero. Its instantaneous velocity is zero, but its acceleration is non-zero. Is that clear? State the rules for finding the number of significant figures in a measurement. There are certain rules. You know, you have not learned. You not learned. You tell me. I taught you. But for what condition? If you take a number, all non-zero digits are significant. First of all, what is the difference? What is the meaning of significant figure? So where do we use significant figures? Why are they even important for us? Correct? Answer for who? Answer. Why would you even use it? In experiment, what do you generally do? You take measurements. So when you measure a particular value, you need to know how many significant figures it has, right? So who decides the number of significant figures? So number of significant, or else I can put my statement like this. The significant figures will also tell you about the precision of that particular experiment. What do you mean by precision? So how correct or accurate your answer is going to be, right? For that you need the number of significant figures. So there are certain rules which you will need to follow. So all non-zero digits are significant. Second, all the zeros between two non-zero digits are, so idhukla you have it in the notes in the material which we gave you. It will be there in that. I'll just read it out, listen. So if you have two non-zero digits, 1 and 5, how many ever zeros you add between those two non-zero digits, they'll become significant. Okay. If at all you have a zero, when will it become insignificant? The zeros which are, so after non-zero, na decimal ka or non-decimal? For decimal, you are saying 2.350. You are saying the zero is insignificant. That zero is not taken into consideration. Is that what you are saying? It is. Now, I'm asking you, when will zeros become insignificant? Decimal point. Whenever you have a decimal point, so for example, if you 0 point, let's say 005 in Rakana. So you need to check where the first non-zero decimal value is starting. So before that, whatever zeros are there, it is insignificant. Okay. Similarly, if you have a number 23500, are these two zeros significant or insignificant? They are insignificant again. So whenever you have the zeros after a non-zero value in a non-decimal number, they become insignificant. Whereas 2.350, the zero after the non-zero value in a decimal value is significant. So these are all the rules that we need to follow. Okay. So you read that notes and go through the lecture, you will understand. I've explained it in detail. Okay. So 16, 17. So state the number of significant figures in the following: 0.2370. Wait, let them guess. Can you guess? At least guess one. So 0.2370. How many digits? How many numbers are there, including all the zeros? So 2 zeros, 237. So there are totally 5 numbers. Okay, insignificant figures are the number of digits. Okay. So can I write the answer for this as 5 here? I should not write it because it is a decimal value. In the decimal value, which zero becomes insignificant? The zero that is there before, the first non-zero digit. So before 2, how many zeros are there? 1. This zero is not significant. Whereas other decimal, after the non-zero digit, if you have a decimal, if you have a zero, it is considered. So what should be the answer? You have 4 significant figures. In a similar way, you have 6.320. It's a decimal value. The zeros after the non-zero digit are considered. So answer will be, for example, had the question been 6230 joule, how many significant figures are there? 3. Because it's a non-decimal number and the zeros after the non-zero value are insignificant. So here the answer will be 3. Reda. So about this in depth, you can learn it from the video. Go through that. 19th one. There are 2 straight lines drawn on the same displacement time graph, making an angle 30 degree and 60 degree with x-axis respectively, as shown in the figure. Which represents greater velocity and what is the ratio of their velocities? So if it is a velocity time graph, slope will give you. We did a problem. Velocity time graph, slope will give you 19th one. 19th one. One is 2, 3 and the question to answer. But what does slope give you? Acceleration. For velocity time graph, slope is acceleration. For a displacement time graph, what will slope be? Slope now, it's not a very big term. Slope is y by x. Y what is there on y-axis? Displacement. X-axis displacement by time. So slope of a displacement time graph is velocity. And slope na enna sonna, if angles are given, what is slope? Tan. Avunu value kudutale tan. Paranga. Slope kenna edirukkinga. What did you write? Tan theta. What is that theta? Theta is the angle made by the line with the x-axis. Ipo enna angles kuduthirukanga? The same angles again, 30 degree and 60 degree. Okay. So they're asking which one represents the greater velocity. Greater velocity means greater angle. So here A has greater velocity or B has greater velocity? B has greater velocity. And what is the ratio of the two velocities? Velocity of A by velocity of B. Enna varum? Tan. Paranga, A is making what angle with the x-axis? Tan 30 divided by, that's it. What will be the answer? The same 1 by 3. Simpler. So whenever there is a graph-based problem, the first thing you need to look at is the slope. Slope another tan of angle made by the line with the x-axis. Seriya? Right. Shall we proceed? The last question in this paper is the velocity of water waves depends on the wavelength lambda. So velocity, listen to this, velocity depends on wavelength lambda. So depends now proportional to wavelength raised to the power A. Okay. Density of water, rho raised to the power B. And acceleration due to gravity raised to the power C. So this is how you do dimensional analysis. So whatever they give, velocity, mostly they'll give only for 3 physical quantities. They'll not give more than that. Okay. Velocity depends now proportional to wavelength power A, density power B, acceleration due to gravity power C. So V will be equal to K times lambda power A, rho power B, and G power C. So what is the next step? It should be dimensionally consistent. So dimensional formula of velocity is equal to K times dimensional value of lambda to the power A into dimensional formula of rho to the power B into the dimensional formula of G to the power C. Okay. Dimensional formula of G to the power C. What is the dimensional formula of B? LT minus 1. Dimensional formula of K. What is the dimensional formula of lambda? Lambda is wavelength. Length to dimensional formula. L. So L power A. What is the dimensional formula of density? First problem, I think we'll get the answer. Density is mass by volume. So M, L minus 3, the whole cube. Sorry, M, L power minus 3. G is acceleration. Acceleration is meter per second square. Upper LT minus 2 to the power C. Okay. So LT minus 1 will be equal to L power, or I'll write M first. M what is the power that is there? M power L power A minus 3B plus C and T power minus 2C. Okay. So comparing both the sides, here it is M power 0. So B is 0. L is A minus 3B plus C is 1 and minus 2C is minus 1, which implies C is equal to half. Okay. If C is equal to half, you substitute it here. A plus half is 1, which implies A is equal to half. So what will you get? A is equal to half, B is equal to 0, C is equal to half. So what should you, where should you substitute this value? You will take and substitute it in this step. Up V என்னவா இருக்கும்? V will be K times lambda power half, then rho power B, rho power 0. So rho power 0 and G power half, which implies V is equal to K into root of lambda into G. Okay, this will be the mathematical formula for velocity, which is dependent on wavelength, density, and acceleration due to gravity. Is there any doubt? Please make a note of this. Done. So these are all the problems. Ashwin, are you clear? To some extent, yes. You're clear. You asked me a problem yesterday. What was it? Can you ask me again? Fundamental. You have it. You have it in your mobile. Yeah, let me know. So there was a doubt asked yesterday. If length, okay. So the question is represent length in terms of fundamental quantities, velocity, gravitational constant is capital G. Capital G then. Planck's constant is H. Okay. See, generally, you know why we use dimensional analysis, right? Means to understand how much does a physical quantity depend on the 7 fundamental quantities. What are the 7 fundamental quantities we have? Mass, length, time, current, temperature, amount of substance, and intensity. Right? These are the 7 quantities. That is why if you see, all the dimensional formula that we write will either be in terms of M, L, T, and here and there you will be using ampere and sometimes Kelvin also. Candela and other things are very little usage for your level at best. Okay, this ampere itself is very less. So Ella we would have written only in terms of MLT only, right? But now what they are saying is, I don't want you to tell me V na velocity that. Speed. What did they give? V then I don't remember. Velocity. Okay. So I don't want you to give me velocity in terms of length and time. They're saying, I want you to write the dimensional formula for length, or not the dimensional formula. Try to find out the value of length in terms of velocity, acceleration, universal gravitation constant, and Planck's constant. Means you need to write that length depends on v power a, g power b, and h power c. Means in this problem, instead of treating mass, length, and time as the fundamental units, they are treating b, g, and h as fundamental units. If at all there is a hypothetical situation where I take b, g, and h as fundamental quantities, what would have been the formula for my length? Puriyudha? Okay, so did you understand? I didn't do anything. The same steps that I followed. So length is directly proportional to v power a, g power b, and h power c. So length is equal to k into v power a, g power b into h power c. Is there any doubt? I hope the concept is clear, no? Is the concept clear? If a dimensional formula of length should be equal to k into the dimensional formula of b raised to the power a, dimensional formula of g raised to the power b, and dimensional formula of h raised to the power c. What is the dimensional formula of L? It is L only. K is it's a dimensionless quantity. What is the dimensional formula of b? LT minus 1 to the power a. What is the dimensional formula of g? Again, Bata. So how do you know that? I know it is tough, but did you see this kind of a formula in your 9th standard? So G is equal to F into R square divided by M1, M2. So the dimensional formula of G is dimensional formula of F. So what is the dimensional formula of F is MLT minus 2 into dimensional formula of R square is L square divided by dimensional formula of M1 into M2 is M square. This will get cancelled. M minus 1 L, M minus 1 L3 T minus 2. Now, so M minus 1 L3 T minus 2 raised to the power B into Planck's constant. Where will you write? In your chemistry, did you learn E is equal to H nu? So H is Planck's constant. So H is equal to E divided by nu. It is not B, it is nu. Nu is frequency. So E is measured in M L square T minus 2 divided by nu is measured in 1 by T. So it will become ML square T minus 1. So here it will be ML square T minus 1 to the power C. So collect all the terms. So it will be M power minus B plus C. L power A plus 3B plus 2C. And T power minus A minus 2B minus C. Okay. So minus B plus C is how much? Minus B plus C is the power of M on the right hand side. What is the power of M on the left hand side? M is not there. So M power 0. Up it will be B is equal to C. Similarly, T's power is minus A minus 2B minus C. What is the power on the left hand side? T time irka left la. Illa what should you write? T power 0. Anything power 0 is 1. So that is also 0. So minus A minus 2C minus C is 0. So minus A is 3C. Is that clear? Similarly, A plus 3B plus 2C is 1. So A is how much? Minus 3C plus B is equal to C. So this is 3C plus 2C is equal to 1. So minus 3C plus 3C are gone. C will be half. If C is half, B is half. If B is half, A is minus 3 by 2. Slightly tough only, but so the expected equation is L is equal to K into B power minus 3 by 2 G power half into H power half. So this is how you need to write. Did you understand what they asked in the problem? It's the same procedure. This is what is called as finding the relation between a physical quantity in terms of other physical quantity using dimensional analysis. This is a very, very, very important application. In every school, they will ask for you. This question you got in your school exam. Eh? Okay. So please make a note of it. Right? Copy it. Check if this answer is matching with page from where you got this. So those all for the day. More I'm not sure how many will come. Their exams are over. Their AD. For you. For you. For you. You can start. You also do. For you, it's starting on Monday. Yeah, that's fine. Okay. So tomorrow I'm just thinking what I'm supposed to start. Less number of students are there. I don't want to start anything new. Anyways, I'll find out and let you know. Okay. So that's it for today. We'll see.
Thank you, sir.
You both have any doubts?